A filter in the request processing pipeline. In the pipeline model, different processes can act upon a request as it travels through the system. In Jakarta server pages, now we are considering a filter in the request processing pipeline. Uh, in the pipeline model, different processes can act upon a request as it travels through the system. There are many names given to the pipeline data processing model. It is often identified as enabling element of model view control MVC web application design, and sometimes it's referenced to as push model of application design in contrast with the more conventional push model. The idea is simple, but you have to think beyond the conventional web application wisdom to get bigger picture. Consider the illustration of the model shown here. The request enters to the system and is shuttled along a pipeline. As it traverses the pipeline, the sequence of processes has to access the content of the request. Each process perform some task on the request, and then it either adjusts to some new attributes or modified the existing attribute as the request of the work. Then the request remain intact until it hits the final stage of the pipeline, which is especially processes called renderers. Examine all work being done to the request and produce the final response. Renders are always called view component in MVC paradigm because they alone are responsible for final presentation of the user. You can see why this is often called push model. The data attributes are fetched by the processors, pushed along the pipeline with the request, and the renders only at the final stage. The another common analogy for pipeline model is the conveyor belt or assembly line. Each processor mirrors the workers or robots along the belt or line. Some of the highly desirable properties of a pipeline model are as follows. The request stays intact as it traverses the pipeline, with the work being carried out only on the attached attributes, sometimes called decorators. Data management, business logic and presentation logic can be cleanly separated into different processors and renderers. The processors can be designed to completely composable, that is changed in any order, or highly specialized to work only with the specific attribute created or modified by the other processors. Multiple renders can compose finally output such as data to XML or HTML via XLLT. The state of the request travel with the request through the pipeline. The processors and renderers don't keep track of the requested independent state at all. This makes it possible to duplicate or shuttle the request and its state before multiple POSIX servers if necessary. In general, designing request handling logic by using pipeline model provides the following: processors and renderers that are readily reusable as components, strong and clear separation between data management and business logic and presentation logic in an application. Applications that are more maintainable, applications that are more adaptable to changing business requirements, robust applications that will be scalable with container technology and hardware advances, web application whose performance is highly optimizable. The last point may not be immediately obvious, but any processes in the pipeline that don't depend on other outcomes can in principle be executed concurrently, perhaps on two physical processes, for instance, and any grouping of the process that has an outcome independent of others can execute continuously. concurrently. In the past, the limitation of container implementation have prevented the use of clean pipeline design model. Server 2.5 has features that bring a dream of creating pipeline applications closer to the reality. Here you can see the request flow, and this is the pipeline here. Here the request flow interacts with processes, and here the request interacts with processor render and is provide response out. Now this is the end of my presentation. Thank you very much for watching it.